Very good morning. Hope you all are fine and enjoying the lectures. Today we will discuss relationship between correlation and covariance matrices. We will also discuss some other matrices called sum square and cross product matrices. We discuss one tutorial. I am sure this lecture will again help you in understanding the multivariate descriptive statistics in a better manner. Let us see the next.
So, this is what your in multivariate descriptive statistic we will talk about. That is why the mean vector, correlation matrix and covariance matrix. Now, you can very easily convert this one. Suppose my covariance matrix is this S11, S12, S1p, 12, 22, 2p, like S1p, 2p, pp. My correlation matrix is this 1, R12, R1p, R12 again 1, R2p. So, like this R1p, R2p 1. So, you create another matrix, diagonal matrix D S. This one is same P cross P matrix. This is P cross P, this also P cross P. Same P cross P matrix, only the diagonal elements will be the variance component of diagonal element will be 0. So, this is S11 0 0 0, 0 S22 0 0, like 0 0 0 0 S P P. So, only diagonal elements are the diagonal elements of DS are the diagonal element of the covariance matrix. Of diagonal elements are 0. If you create like this, then suppose you know S, you can just with one click you can find out that R is ds to the power half S ds to the power minus half, both case minus half, ds to the power minus half. If you use MATLAB, you give this MATLAB now straight away will calculate all those things from the data, but suppose you want to do the conversion, even in Excel also you can do this. Getting me? What you are doing? You most of the time you may be knowing this one, that variance component. Once you know S, you know the variance covariance also, you want to calculate R. Suppose you know this variance component are known and correlation is known, correlation matrix is known, you want to go to covariance matrix from correlation matrix. What you have to do? You have to write like this, plus half. So, this one, this is basically from covariance to correlation, and here correlation to covariance. Only thing you want to require in the second case, the variance component of all the variables considered. Okay. Another important concept in multivariate data analysis is sum square and cross product matrix. Sum square and cross product matrix, which is known as SSCP, sum square and cross product. Okay. So, if you see the when you calculate the covariance matrix, correlation matrix, we have used the formula x, that one for n minus 1 cross S equal to x star transpose x star we have used. We have used n minus 1 R equal to x tilde transpose x tilde we have used, where both x star and x tilde are basically transposed, not transposed, transformed transformed matrix from the original data, which is x. So, if x is now, suppose x I am writing like this, x 11, x 21, x 31, x 12, x 22, x 32. You do like this. Now, you calculate x transpose x, what will happen here? You will be getting like this, x I 1 square I equal to 1 2 3. Here the I equal to 1 2 3 x I 1 x I 2. Here I equal to 1 2 3 x I 1 x I 2. Here x I 2 square I equal to 1 2 3. I have taken 3 cross 2. If you multiply, you will be getting this, because earlier we have seen subtracted by mean and for divided by standard deviation case, we have seen we got similar formula. Now, the same thing, if you think from the p cross p variable point of view, then x transpose x will be a p cross p, because x transpose, this one is p cross n and this one is n cross p, you will be getting like this. So, your matrix will be like this, sum total x I 1 square, then x I 1 x I 2, then your x I 1 x I p. Here x I 1 x I 2, here x I 2 square, then x I 2 x I p. In similarity, I am writing all those things, x I 1 x I p, x I 2 x I p, then x I p square. Okay. So, it is a p cross p matrix. Correct. Then I equal to I definitely equal to 1 to n, all cases. These three matrices like x transpose x, x star transpose x star, x tilde transpose x tilde, these are all sum square and cross product matrices, all SSCP. Why? You see now, these are the sum square, all diagonal elements are sum square, and off diagonal you see cross product, all off diagonal are cross product. So, sum squares for the variance, cross product for the covariance. So, that means from this matrix also, once you know this, you can, we can go from the we use this or this matrix, but ultimately we can calculate the descriptive statistics like covariance and correlation matrix. This one is very important matrix. Later on, particularly in regression, you will be using this matrix. Now, let us see that how to calculate. Suppose this is the problem given, okay, that compute S and R for the data given. This data set you have seen earlier. So, I have used Excel only. Using Excel I have created. So, this is my data matrix. I want to compute the mean. Then as there are n data points, so I created one unit vector with n data points. So, my n is 12 here. So, it is 12 cross 1 vector. Then x bar is 1 by 12 x transpose 1. When I multiply all those things, I got these values. So, profit mean is 10.67, then sales volume 102.75, 7.92 is your absenteeism, then breakdown 59.33 and 1.06 is the that M ratio case. So, your first step will be this, find out x bar, and you use this type of formulation. Then what you require to calculate? You require to calculate S. You require converting this x value to x star. That means each of the, suppose 10 minus 10.67, that is why minus 0.67 is coming here, x star. Once you get this, this is the formula, S is 1 by n minus 1, x star transpose x star, this will give you this value. Okay. So, if you calculate on the left hand side, the bottom portion, this is nothing but SSCP matrix, x star transpose x star. You can do the same thing now. We are interested to know that tilde. Here this is basically x tilde, this one x tilde transpose x tilde, this transpose part is missing, x tilde transpose x tilde, and R is 1 by 11 into x tilde transpose x tilde, you are getting like this. You see, once you go by this way calculating, you will be getting all the diagonal elements 1. If you do not get that, there is a problem. You have any questions so far? Okay. Now we will go to, although next class I will be explaining in detail, when we will start that multivariate normal distribution. What we have assumed here? We have assumed here is x, that is a variable vector x1, x2 dot dot xp, that is p cross 1, and we assume that this follows normal distribution, that is multivariate normal, which will be denoted by like this np and mu and sigma. Okay. Now, you are well accustomed with the nomenclature, in the sense you know that mean is mean vector. If there is p cross 1 variable, then my mean is again p cross 1, that is mu 1, mu 2, mu p. And you also know this one, this is nothing but covariance matrix. So, this covariance matrix is our p cross p matrix, sigma 1 1, sigma 1 2, sigma 1 p, sigma 1 2, sigma 2 2, sigma 2 p, sigma 1 p, sigma 2 p, sigma p p. Multivariate normal distribution is characterized by p variable with parameter, that is mu, that is the mean vector, and covariance matrix, correct. So, please remember these are population parameters, these two are population parameters. So far we have not discussed about that whether the data is coming from multivariate normal or not, but ultimately we will be going to multivariate normal distribution, because most of the models that will be rely on this assumption, multivariate normality. Okay. Now, when p equal to 1, that is univariate normal. Now, what is the definition, the probability density function of univariate normal? Suppose x is a random variable which is univariate normal with mu and sigma square. Then, if I want to know what is your probability density function of x, this is your f x PDF, you will write 1 by root over 2 pi sigma square e to the power minus half x minus mu by sigma square, where minus infinite less than x less than plus infinite. correct. So, this is what is you have seen earlier that this is what our normal distribution is. Normal distribution is. So, what will be the equivalent distribution when number of variable is more than 1? That will be our starting point in the next class. Okay then, thank you.